In this section, we're going to talk about Gauss-Jordan elimination. We use this to solve system of equations, basically using the concept of RREF. Suppose you had the equation 2x plus 3y is equal to 8, and the equation 1x minus 2y is equal to negative 3. Now, we're going to do this problem twice. First, using matrices, not using matrices and then using matrices. Students always say, oh my goodness, using matrices is so much harder. Well, let's see if that's true. To solve this, the first thing you should realize, well, let's eliminate the x's. And since this is a 2 and this is a 1, if I'm just going to double row 1. I'm going to double equation 2, because that will put a 2 right here. I already have 2x right above, 2x below. I'll subtract. So row 1, we're not doing anything to. I meant to say equation 1, we're not doing anything to it. Equation number 2, we'll multiply by 2. 2 times 1x is 2x minus 2 times 2y is 4y equals 2 times negative 3 is negative 6. And then I subtract. 2x's, take away 2x's, they cancel to 0. 3y, take away negative 4y, change and change, that gives you 7y. 8, take away a negative 6, this is 14. Change and change, you get 14. So the 7y's equals 14. 7 times this unknown number is 14. Well, the number is not unknown anymore. It's 2. 7 times 2 is 14. Okay, let's pause right here and go on and do this using matrices. What you do to use matrices is the first thing you do is you write down what's called a coefficient matrix. That is, you write this down except you don't write down x, y's, and equals. That is, you write 2, 3, and then 8. 2, 3, and 8. Second row, 1, negative 2, and negative 3. 1, negative 2, negative 3. And then, for the equal signs, you put a line. That is, you kind of separate those right-hand numbers. When you put a line in the matrix, like I just did, it is now called an augmented matrix. It's an augmented matrix. Now, the right-hand side, we don't worry about. Everything else, that is, these numbers, we want to get it into RREF form. But whatever we do to row 1, we also do to the right-hand side. We do to the 8. Whatever we do to row 2, we also do to negative 3. That is, row 1 is 2, 3, as well as 8. Row 2 is 1, negative 2, negative 3. All right, so in row 1, the first non-zero entry is the 2. There's no above it, but I want below it to be 0. I want this 1 to be 0. Well, the first common multiple between 2 and 1 is 2. Well, row 1 already has a 2. Now, in the first position, if I double row 2, then this first position will have a 2. And since they're both 2's, I will subtract. and I'll get 0. So row 1 is 2, 3, 8. You double row 2. 2 times 1 is 2. 2 times negative 2 is negative 4. 2 times negative 3 is negative 6. And we subtract these two rows. And we will get the new row 2. 2 minus 2 by design is 0. 3 minus a negative 4 is 7. 8 minus a negative 6 is 14. So this is row equivalent to 2, 3, 8, 0, 7, and 14. Haven't mentioned this till now, but when it comes to reducing a matrix, you should always, when possible, divide to make the numbers smaller, but not introduce fractions. I could divide every entry in row 2 by 7, because 7 goes evenly into those three numbers. So let's do that. 2, 3, and 8. 0 divided by 7. 7 divided by 7. 14 divided by 7. Okay. So basically, we've done the same steps on the left as we did on the right. I took the first equation on the left, and I subtracted 2 times the second equation. Row 1 just means the first equation. Row 2 means the second equation. First equation minus 2 times the second equation. That's exactly what I did here. I just didn't write down x's and y's. And then what did I do? Maybe I didn't say it, but I divided both sides by 7. What would we do next? So I am done with column 1. There's my first non-zero entry in row 1. What's below it is 0. Row 2, here is my first non-zero entry. I need to get what's above it to be 0. Well, between 3 and 1, the first common multiple is 3. Due to lack of space, I'm just going to put an arrow here. What am I going to do to it? Well, I'm going to triple the second row. That puts us 3 there. And I'm going to do nothing to the first row, and then I'm going to subtract. So here is row 1, and 3 times row 2 is this. And when I subtract, 2 minus 0, 3 minus 3, 8 minus 6. So for the first row is now 2, 0, 2, 0, 1, 2. So other than getting 1s for the leading entries, this part is in RREF form. So, but that's with an exception. Getting rid of the exception just means to divide row 1 by 2. Because 2 divided by 2 gives me 1. 0 divided by 2 happens to be 0. 2 divided by 2 is 1. 0, 1, 2. Okay. Now, the very last thing is, and I'm going to try to get rid of everything to make it less confusing. We need to know how to read that last matrix. Because somehow we're going to figure out what the answer is just by you looking at that last matrix. Actually, let me erase this and put it back. The matrix that we had over here a few minutes ago was 2, 3, 8, 1, negative 2, negative 3. But that well, let me write this down more neatly. I wrote on it a lot. These two correspond to one another. 2x plus 3y equals 8. 1 minus 1x minus 2y equals negative 3. Should be able to go back and forth with this. For example, what equations does this first row give us? The answer is the first column are x's. 3 means plus 3. The second column were y's. Actually, I'm saying what both rows give us. And the line stood for equals. Oh, look at this. They're exactly the same now. This last matrix at the bottom right, let me blow it up. What does it mean? Well, let me write it down again. It's x, 1x plus 0y, 0x plus 1y equals 1 and 2. Equals 1 and 2. Okay. But 0y is 0. 1 times x is x. X plus 0, that's just x. And it equals 1. 0x's are 0. Add 1y, you get 1y. But 1y is just y. This is just y. And it equals 2. And there is your answer. 1x equals 1. 1y equals 2. 1x equals that number. 1y equals that number. It'd be a whole nother story if that 0 was an 8. Now it would mean that 8x plus 1y equals 2. But if the 8 happens to be a 0, just remember that 0 times any number is 0. And if you have 0 and you add y to it, you get y. And it still equals 2. So why don't we review that step for a minute or two. That is for a couple of examples. If the first column is x and the next column is y and the third column is z, what would this matrix give us? The first equation says, well, the first row says 1x plus no y's plus no z's, which is just 1x or x. 1x is x. 1 times x is x. But adding 0, 0 y's is 0. 0 times z is 0. Adding 0 to x gives you x equals 3. X equals 3. 0x plus 1y. Well, 0x is 0. 1 times y is y. 0 plus y is y. 0 times z is 0. So basically you have 0 from 0x plus y from 1y plus 0 which came from 0z. This is y. And it equals -2. Y is equal to -2. The next one is z equals 4, because 0 x's are 0, plus 0 times y is 0, plus 1 times z is z. 0 plus 0 plus z is z, and it equals 4. You might see the answer in matrix form. Oops. X, Y, Z is equal to 3, negative 2, 4. So once you get it into reduced echelon, row reduced echelon form, you need to be able to read the answer. That's quite important. You need to be able to read the answer. Let's try another one. X plus 2y minus 3z, that's 0. 2x minus y minus 2z, negative 1. And x plus y minus z is 1. A couple of comments. You need to be mathematically mature enough to know that there are understood ones in the places I just denoted. Of course, y is 1y, x is the same as 1x. And now you just write down the coefficient matrix, including signs. You write down the numbers in front of the x's. 1, 2, 1. Including the signs. Then you write down the numbers in front of the y's. 2, negative 1, 1. And then the numbers in front of the z's. Negative 3, negative 2, negative 1. Then you augment it. And here is your augmented matrix. It's called a coefficient matrix as well. Now, what do I want to comment? If you had another equation, or if one of these equations was just 2x minus z is 4, you need to realize that this is 2x plus no y's. I can always add 0 to an equation. 0 times y is 0, minus the understood 1z equals 4. So that row would be written that way. Insert that 0. And now let's reduce this matrix. In fact, once I erase this, I'm going to write the matrix that remains on the board on the right-hand side. And we REF the matrix. Okay, there it is. First row, the leading entry is in the first column position. If it wasn't, I might interchange, I put row 2 up there. If this one were a 0, then I would put row 2 up there, or row 3. If all 3 entries are 0, wonderful. Go on to column 2. So I have a 1 here. I want to get what's below it to be 0. 1s are really friendly because I can get 1 to be any number I want. I want a 2 to be where the 1 is. I double the first row. 2 times row 1. It put a 2 in that first position. And row 2 already has a 2 in the first position. So I just do elementary school subtraction. Now, I want to get this entry to be 0. I'm going to use that first row. Well, they're both 1s. I'll just do row 3 minus row 1. It doesn't matter if you do row 3 minus row 1 or row 1 minus row 3. That doesn't matter. You'll get different rows, but in the end, you'll get the same answer. Okay, so we are not doing anything to row 1. Row 2. We're going to do 2 times row 1. 2 times 1, 2 times 2, 2 times negative 3, 2 times 0. And then we're going to write down row 2, which is 2, negative 1, negative 2, negative 1, and we are going to subtract. And this is going to be the new row 2. 2 minus 2 is 0. 4 minus a negative 1 is 5. Negative 6 minus a negative 2 is negative 4. And 0 take away a negative 1 is positive 1. 0, 5, negative 4, 1. That is the new row 2. Now row 3. We don't have to scale any of the rows. We're not multiplying any of the rows by anything. That is, we'll just do it. 1 minus 1 is 0. 1 minus 2 is negative 1. 1 minus a negative 3 is 2. And 1 minus 0 is 1. Okay, so column 1 is now complete. I have a non-zero entry, and what's below it is 0. I don't care if the first non-zero entry is 1 or 21. I'll deal with that at the end. And you should always look to see if any row can be divided by any number. For example, I would love to divide by 5 right now, but I can't. The first non-zero entry in row 2 is the 5. I want to get the 2 and the negative 1 to be 0. Using row 2, using that 5. Well, between 2 and 5, their LCM is 10. I'm going to multiply row 1 by 5. That will put a 10 here. And I will double row 2. That will put a 10 here. If they're both 10s, I'll subtract. Let me write that a little bit better. Five times row 1 minus 2 times row 2. Okay. Now, what am I going to do to row 3? I have a 5 here and a negative 1, or a 1. I don't care about signs. 5 and 1. 5's the winner. I'm going to keep row 2 the same, but I'm going to multiply row 3 by 5. So if I keep row 2 the same, that puts a 5 in that position. If I multiply row 3 by 5, I'll get a negative 5 in that position. If I add, I get 0. So I'm going to add. Okay, so let's do our arithmetic. Tons and tons of arithmetics in these problems. So we're not doing anything to row 2. The reason I know that so easily is I didn't put anything there. Okay, 5 times row 1. 5 times 1, 5 times 2, 5 times negative 3, 5 times 0. And I take away 2 row 2's. 2 times 0, 2 times 5, 2 times negative 4, 2 times 1. And I subtract. 5 minus 0 is 5. 10 minus 10 is 0. It's friendly to do subtraction in those two. Negative 15 minus a negative 8 is negative 7. 0 minus 2 is negative 2. And I don't know why this didn't come out earlier. Okay. So right now, 5 row 1s. This answer is a new row 1. 5, 0, negative 7, negative 2. See, there's no point in getting this to be a 1 because now it's a 5. You know, if this were not a 1, I got it to be a 1. So now it's a 1. But now it's a 5 now. Don't get the leading ones to the very end. Doesn't matter what your textbook has. It involves the introduction of fractions. Okay. Row 2, I'm doing this here now. Row 2 is 0, 5, negative 4, 1, and 5 times row 3. 5 times 0, 5 times negative 1, 5 times 2, and 5 times 5. Now I add 0 plus 0, 5 plus negative 5, negative 4 plus 10, 1 plus 5. 0, 0, 6, 6. Column number 2 is done. It has the leading entry, row 2 has the leading entry of 5. Row 2 has a leading entry of 5, and what's above and below it is 0. So now we go on to row 3, and there's a 6 here. We want to get what's above it and below it is 0. But as I said earlier, you really should try to see if you can divide the rows by anything to get the numbers to be smaller. For example, the LCM of 6 and 7, it's not a friendly number, it's 42. Between negative 4 and 6, it's not negative 4, it's 12. What you should do is divide rows 3 by 6. So the first row does not change. The second row does not change. This third row does. 0 divided by 6 is 0. 6 divided by 6 and 6 divided by 6 are 1s. Okay. So now it's a little bit easier using the 1 to get the number, to use this one to get the numbers above and below them to be 0. For example, if I keep row 1 the same, I have, ignoring the signs for a moment, I have a 7 there. Well, if I multiply row 2 by 7, I'll have a 7 here. Now we take into account the signs. This will be negative 7, this will be 7, or positive 7. If you add, you'll get 0. This is a negative 4. Just let it stay. Because if I multiply rows 3 by 4, I'll have a 4 here. You have a negative 4 and a 4. You add them, and like magic, you get 0. It's just magic. That's all it is. Row 1 plus 7 row 2's. Row 1 is 5, 0, negative 7, negative 2, and 7 rows 3s, I meant to say. 7 rows 3s is 7 rows 3s is 0, 0, 7, 7. And if you add these, you get 5, 0, 0, 5. Okay, so row 1 is 5, 0, 0, 5. So erase this side work. You really should do your side work on the side. Students are forever doing the side work right in the middle of the problem. Don't do that. Row 2, and we're going to add 4 rows 3s. Well, row 2 is 0, 5, negative 4, 1. And row 2 is 0, 0. 4 times row 3 is 0, 0, 4, 4. And when you add these, you get 0, 5, 0, 5. This is new row 2. 0, 5, 0, 5. And the last row isn't changing. Okay. Rows 3, here's my leading non-zero entry. Above and below is 0. Okay. So other than getting the ones on the diagonal, this matrix, our last matrix, is in RREF form. But we don't want an exception. So we're going to take row 1, and we're going to divide by that number. And then we're going to take row 2, and we're going to divide by the first non-zero entry. And row 3, if you insist, we divide by 1, which really means don't do anything. So what we get is 5 divided by 5, 0 divided by 5, 0 divided by 5, 5 divided by 5, 0 divided by 5 in row 2, 5 divided by 5, 0 divided by 5, 5 divided by 5. And row 3 did not change. The first column, if you remember, were x, and the second column y, and the third is z. This tells me what x, y, and z equal. 1x is 1. 1y is 1. And z is 1. X, y, and z, they were all 1s. Okay, I'm going to finish up here. We're going to have to come back and do some more of these row reducing type problems when we're going to talk about consistent and inconsistent equations. So we're going to see more of this.